So thanks everyone for coming. This afternoon, with the help of my colleague Brian, we will be discussing and showing you how you can create modern architectures with Azure SQL Database. So let's get straight to the point. Of course, remember to do the survey. You have the QR code here, and to just download the application and make sure that you do it after the session. Just a few words about me. Davide Mauri, I'm a PM in the Azure SQL team. I'm focused specifically on developers and development engagement and experience. So hopefully most of you are developers here. Who are developers here? Interesting. Okay, don't be shy. Raise your hands. Okay, cool. So you will be probably familiar with what I will be discussing at the beginning, but hopefully me and Brian will show you something interesting after a few slides of introduction. Basically, we'll go over what I showed during the keynote about how Azure SQL can actually be immersed and included into modern applications by creating and consuming REST and GraphQL API. That's all about me. You also find all the information about my blogs and my Twitter account and whatever there. Brian, do you want to spend a couple of words about yourself? Maybe, yeah, stand up, show your face to everyone.
All right, good afternoon. I'm a fellow product manager with Davide, same group pretty much.
Yeah, absolutely.
And I will be, once he hands it off, I will be going through some of the REST and functions things that we can now do with the database for you developers in all your languages and whatnot.
Cool.
Not as exciting as a
No, it is. Come on, don't play your stuff. It's super cool. And so here's the agenda, but let's move directly. It's very simple, the agenda. So modern architectures, probably just a few mention on of patterns or architecture you are probably already familiar with. And then we'll go deep dive into what Azure SQL can help you, how Azure SQL can help you to implement those patterns. So the first one is very common. It's full stack, right? Probably every one of you here already knows about the full stack, which basically means that you have a database behind the scene, a backend that communicates with the database, usually on the same server or let's say in the middle tier somewhere in another microservices, maybe even you have the front end. The front end will actually emit HTML that is consumed by the client. When someone browses the website and fill out a form, they will send you back some text data. This is very typical. It's nothing really new, which basically says we have this three-layer architecture, the database, the backend, where we also run the front end sometimes, and the client. Now, the new stuff, the new approach to a full stack application, it's called, or architecture is called Jumpstack, where actually you see that the front end is completely pushed on the client. So the backend doesn't emit HTML anymore, but it emits JSON. So the backend is just a middle tier for API, basically. And on the front end, or better, on the client, you will get the JSON and put all the logic, typically in JavaScript, using JavaScript framework, if you are building a web page, or if you are on a mobile application using the mobile framework for the OS you are using. But basically, the important part here is that the API, the backend are really API. So you really care about getting some JSON that contains the information about what you need to provide, like an order, information about the profile of someone or whatever. The backend API take that JSON request, do something, but at the end of the day will be some query executed on the database return the data, the backend API transform it into something that can be understood by the front end, typically JSON today, and then the front end is rendered on the client. So this is just a kind of evolution of the full stack called the Jamstack. Also, you have the link with all the details about Jamstack when it was defined first and so on and so forth, but that's basically it. Now, another common pattern that is now emerging is to split the backend into several services, one for each different front end that you have to serve. So you will have a backend that will serve the web front end. You will have a backend that will serve only the mobile front end. And depending on how specialized you want to build your backend, you may even have different backend for different mobile, maybe one for iOS, another for Android or whatever. The idea is to optimize the API so that they will be perfect for the front end that they are serving. And that's why this pattern is known as backend for front ends. all the patterns I'm mentioning here have a link to our architecture website. So if you want to know more, you can just deep dive into it. Someone may disagree on the architecture I drawn here, because here I've shown one database layer behind the scene, even if I call it databases, because many architects will actually argue that you should have one database per specific backend. So instead of having one big database here that collects all the data coming from all the different services and backend, you should have what was called polyglot persistence, which basically you mean that you have one database for each backend API. I am not super fan of that architecture because it creates a lot of friction in terms of data integration. But if you want, you can do that too. Or again, you can use just one database here to serve all your backend. But the point here is that you have one backend for frontend. So as you can see, building a backend is really the key point, because in all the architectures I just described, the backend is basically the translation layer and the logic layer, where you take the input from your user, do some transformation, do your business logic, and then communicate with the database. So the first thing that I will show you is how Azure SQL and a tool called Data API Builder that I, again, showed during the keynote can help you to automatically generate your backend, so that if you only have to do create, read, update, and delete operation, which are basically the 80% of the use cases, you don't have to write the backend on your own. You can just configure Data API Builder to build the HTTP, to handle the HTTP request or the GraphQL request on your behalf without writing code. That will, of course, save you a lot of time if, again, you only need to support CRUD operation, create, read, update, and delete operation, which, again, are the most common operations you probably want to support. Now, if you want to go into something more complex, you probably start to go into event-driven architectures. CQRS is one of the most common and well-known, which, again, I'm summarizing very quickly. It means that you say, I have a very complex data model. I want to split this data model in two, so that I can create one data model that is super fast to write, so I can sustain a huge amount of ingestion, like orders during the Black Friday or whatever, because I optimize my data model for sustaining writes. But I also understand that people need to read my data, right? So I will create another data model that is optimized for reads, and I will find some way to keep these two models in sync. So every time I change something in my write model, I will also update the read model in order to speed up all the reads, right? So this is common, and as you probably already understand, the key point is make sure that whenever someone or something changes the data, an event that fires up the update of the read model in order to have the data refreshed is super important, because that's basically the key to make sure that your read model always shows the latest data that you have. One way to implement the logic, or to define the logic on how this event flows so that you can actually keep the read and the write model in sync, is called event sourcing, which again is another, I would say, complex pattern that tells you how you can turn basically everything into an event. And as you can see here, it shows something called a materialized view. Materialized view is nothing more than a read model implemented that you have to maintain. Basically, every time an event happens, like the cart is created, it is an example for a shopping cart, or an item is added, an event is sent, and both the write and the read model are updated using some specialized logic. I will not go into details, but again, I want to highlight that the key point here is handling event, emitting and managing events, right? And the third one is called the transactional outbox pattern, where again, this is useful when you want to have transaction, but at the same time, you want to also use one of the pattern before, where they don't understand transaction, but still you need to do some transactional logic, and you want to then take advantage of the database to do that, but at the same time you need to send an event somewhere. So you basically build this, you apply this transactional outbox pattern that again is based on event and publishing event to a bus where other clients or other services can use the event. So the point here is that event-driven architectures are absolutely common today, especially for scalability reasons. How Azure SQL can help us to turn our data into an event or take the event and act on our data. And that's what Brian will show you with several features that we have added lately. So let me start with the first step. Let's start saying that we have the most basic need. We need to create a website to present some data and to collect some data from the end users. And we want to do it properly, so we will use a full stack, and more specifically, a Jamstack architecture, which means we will have Azure SQL behind the scene. We need to build the backend, and the front end is something that we will build using Vue, JS, or React, or Angular, or say your favorite framework, even plain HTML. Actually, just to make sure that I can show this to everyone, I will just be using vanilla HTML, vanilla JavaScript, and jQuery, if you remember this very old library, to show how you can easily consume data once it's exposed as an API. So what is Data API Builder and why we need that? Because making data available as an API is something that I hear every customer I speak with to be one of the highest priority jobs or tasks that they plan to do in this year or the next one. Because the idea is that the moment I take my data in my table and I publish it as an API, I enable all developers using any framework, any operating system, any language to interact and consume my data, right? Of course, this is a huge value because this means that my company can be more efficient. I don't need to hire specific people that knows, let's say, only T-SQL. Well, of course, if they know T-SQL, it's better, but they don't have to, right? Data API Builder is a tool that we created, open source, free, available both in Azure and offline. So if you are just using SQL Server, you don't care about the cloud at all, you can still use Data API Builder on premises that will take your table, view, or store a procedure and immediately turn it into an API. Now, this seems to be, okay, that's interesting, but why I can't do it on my own? Well, you can do. It's probably take 10 lines of code to do that. But then your user will start to say, oh, that's cool, but you are returning 1 million of rows. Can you paginate it? Oh, sorry, forgot. We need to do add pagination. Well, but I also need authentication. Right, we also need to add authentication. So 10 lines are already 50. And then you want to be able to filter on any field and any column. Then it's another 50 line of code. And then you also want to be able to order the data or to sort the data when it's returned. And then you also want to support not only REST, but GraphQL. So the number of lines of code at the beginning is super simple, quickly starts to add up and becomes a pretty big project, right? You will probably realize that if you have done this for one table, then you have to do it for another table, for another view, for a storage procedure, and so on and so forth. So what we figured out is that it will be useful to have a tool that allows you to do whatever I just said without writing code. So you just configure a configuration file, and then we will start a service that is listening to some HTTP ports and will give you or give your user access to the database using REST and GraphQL. So the only thing you need to do is your relational schema you already have. Now you may be wondering here because we have something else here. Because Data API Builder is, of course, absolutely focused on Azure SQL, and it works perfectly. But it's also focused on all the other databases we support in Azure. So it works also with Postgres, MySQL, and Cosmos DB. So if you have any of these databases in Azure or on premises, set aside for Cosmos DB that doesn't exist on premises, you can use Data API Builder, again, for free to make sure that any of your databases can be seen as a REST API. Then that's the important part. You will have to configure a configuration file. This is something we'll do together. And then basically we take care of everything else. What we do for you, we create the REST and GraphQL CRUD API for everything, as I mentioned. We add support for pagination, filtering, sorting, and projection. So any table exposed can be filtered using GraphQL or REST, paginated, and so on and so forth. We support authentication. We support also authorization via something that I'll show you briefly that allows you to specify who can see what, even at the row level, so kind of row level security. We have implemented our own in Data API Builder since we have to be compatible with all databases, but if you are using Azure SQL or SQL Server and already using row level security, you can just use that with Data API Builder too. And the only thing you have to do in order to make this work is install Data API Builder using .NET tool install. And this is well documented in documentation, but basically it's just one line. .NET tool install Microsoft Data API Builder. It will download Data API Builder for you, and it's available on your machine. Then you initialize the configuration file with dub init. Add the entities you want to expose, like a table, a view, a store, a procedure via dub add, and then you do dub start, and you're done. So let me show it to you in real time. Okay, so let's start. This is a folder that I already prepared. I already have, okay, let me delete. Actually, let me go here and let me show you that. Let's delete this. Okay, so I removed the configuration file. These are already made, so then I can speed up some demos I want to show you. But basically, the important one, that configuration file, which is the one that by default is used, now it's not there anymore, so I need to configure one. So let's do dub init, and I initialize Data API Builder to be used against a SQL Server database. I want to use the development mode, so I have more logs, and I will use a connection string that is stored in an environment variable that I have already set. Perfect, let me go here, and now we have the configuration file. Now, the configuration file contains a lot of stuff. The important part are the data source, which tells Data API Builder what database are you using. The runtime basically defines if you really want to support GraphQL and the REST, or maybe you want to disable one of those. The path at which the REST and the GraphQL listeners will listen to, the development mode, information about CORS. If you are a web developer, you will very well know what CORS is, which is needed once I want to use Data API Builder on its own, but you will see that you can even forget about CORS issues if you use Data API Builder with static web apps, and the authentication mode. Right now, we are using static web apps, which is the easiest, but which also means that if I'm using Data API Builder offline, basically we don't support authentication because static web apps is only an Azure feature. And then the entities are empty, which means that by default, if I start the Data API Builder right now, nothing will be published. It will be listening, but it will not answer to any request. So what I want to do is SQL command open ADS. So let me open Azure Data Studio, connect to the database where I already have prepared a couple of tables. And what I will be doing is exposing those tables and also creating the relationship for those tables in order to allow GraphQL navigation to be enabled. So I am connected to my database, my local database again. I created this database called VS Live, and we have the to-do table that contains some to-dos. And then each table can be set in a category. So I have my category table that, as you can guess, contains information about categories. And let me also show you something interesting here, where category ID equal the demo category. Here, all the IDs have an owner associated. If an ID should be available to anyone, it's marked as public. So I don't care who is logging in. I will always show that ID. If, and in my mind, the idea is that if I logged in, then only the to-do I own, I should be able to see and manage, right? So after I log in, I should be able only to see mine and not the one that belongs to John or that are public or belong to someone else. So we also want to make sure that even using Data API Builder, we can properly set access rules to make sure that only the data that are supposed to be seen by someone are seen by that person or that entity. Okay, let's start. First of all, without caring about authentication, at least at the beginning, what I have to do, and let me go here, and is just dub add, and then let me add the to-dos. So I'm adding the table called DBO to-dos, the one I showed to you just right now. Oh, nope, that's me that I have to remember to speed up. The permission means that anyone can see anything, and that's where my REST API will be exposed. That's it. You will see that now the configuration file contains something for the to-do entity. Now, I also want to expose the categories, and I will be doing the same. I just give it a name to the object I'm exposing, and then I will say this is the source table, these are the permission, anonymous means anyone can do star, everything, create, delete, update, and read the table, and this is the name at which my entity will be available. And now I can do dub start, and if I open, for example, this page here, and I go, ultimately means everything is good, so I go to GraphQL, for example, and I have a playground, and I can go, let me just create a new one. So we also provide a playground to interact with GraphQL, for example. So here I can do, for example, let's go with the categories. Let's create, first of all, let's zoom in a bit. So query, if you're familiar with GraphQL, this should look familiar to you, otherwise we'll switch to REST. So let's just me show you all the oh, sorry, this should be not to-dos, but I said categories, yes. I want to show all, and what I want to have is the ID and the category name. Okay, thank you, format. Nice, here are all my categories, right? So this is the query, and the query we are running behind the scene for you is shown here since we are running in development mode. So very nice, in a second, now my data is available as a GraphQL API. I can also, of course, also list the to-dos if I want. And it's available as an API. So I can just, for example, take an HTML page. Let me show you this URL here. And in this case, I will be using REST instead of GraphQL. So what I'm doing is connecting to my /API/to-dos, API because that is where I configured the configuration file, this one here. That is where my REST will listen to, and then to-do because it's the path at which my to-do table is exposed. So that's why here you see API/to-dos, and then I have filter because I want to only show you the category that belongs to this category ID. I only want to show the first 10, and then I want to order everything by position. That's my table in REST format. Actually, this is JSON, right? Which means that if I am working on the front end, so JavaScript running on my client, the only thing I have to do is on my HTML page, simply do a fetch, right? And then get the response as JSON, and then I can manipulate my JSON and my DOM as I would do normally. So I could just run this. The only thing I have to do is configure also CORS, because if I'm running the index using, for example, this live server, there will be two different servers running, and as you know, CORS will prevent one to connect to the other. So we also, I told you that we also support CORS. So let me just stop this configuration, clear, and run dub start, and specify another configuration, which is exactly equal to the one I just built, but as CORS configured, which is only this thing here. I'm saying Data API Builder will accept a request from another server, always running on my machine, instead of rejecting it. And again, if you are a web developer, you know the pain of CORS. So by just configuring that, you solve all that pain. And if I now open my live server here, yeah, here's the list. So I just created a full stack application because my client is receiving JSON by calling a REST endpoint, manipulating the JSON to create the HTML on the fly. And in fact, I'm doing a for each on my object, and I'm injecting an li element in my list to create the proper list. And that's it. As a front-end developer, or even a full-stack developer, the entire backend API is done. I can create here a next button to go to the next page. I can create here a text box to filter for specific categories. The backend is done. I don't have to worry about it anymore. Okay. So last thing I want to do to show you is we still have a problem here. So I solved the backend problem because now my data is available as REST, which means I can manipulate it from my frontend. But as you can see here, I'm seeing data that doesn't belong to me. I see data that belongs to John, someone else. So how can I enable also authentication? So I will just switch to the one I already prepared. So first of all, in the authentication section, since I'm running locally, I'm saying, okay, I want to use Azure Active Directory to authenticate the request. So if you're a web developer, you know very well how to set up an auth2 authentication process so you can get a bearer token after you have used an authentication provider to authenticate the request coming in. But the long story short, usually you have, let me open another one here. Let's do AZ account get, let me just copy and paste the sample I have. Yep, here we go. Let's say that you have some way, depending on the framework you use, so that the front end can actually provide a token that represents the user that is logging into your application, right? What is called a bearer token. Again, I'm assuming you are familiar with this concept. And if you take a look at the bearer token that I just generated, and I'm not using any front end because the scope of this session is not to show how you can generate a token from the front end, but just how you can use the token. The token tells the system who I am. So I'm me. That's good because I authenticated against Azure. I provided my credentials, and Azure returned a token that represents myself. And my preferred username is the one that I want to use, for example, to filter out all the elements and make sure that I can only see the elements that belongs to me. So the only thing I have to do in Data API Builder to make this happen is configure who is performing the authentication. In this case, we decided Azure Active Directory. And then define in each entity I want to secure the policies. Policies here says, make sure that the column called owner ID, item refer to the table that is backing up the entity. So in our case, the entity to-dos is created based on the table DBO to-dos. So owner ID must be a column of to-dos, and it is this column here. So the value of the column owner ID must be equal to public if there is no authentication at all. But if someone is authenticated, then show only the rows for which the owner ID is equal the preferred username. Okay? So what this happens is that if I now run this the configuration, so let me stop the configuration here and use the one configured to use Azure Active Directory. What will happen right now, and let me go, for example, I think I have a file open here. Okay. No, not this one. Here. So here, the very first query I did, I just asked, return me all the to-do that belong to a certain category. And as you can see here, I was able to see the public, but even the to-dos owned by someone. Now that I am using the configuration that has been configured to also properly use authentication and authorization, since via the browser right now, I'm not specifying any token, I would expect to fall in this role. And so I will only be able to see the public item. Let's see if it's true. Refresh. And it is true now, only the public item. Because right now my request is anonymous. I am not specifying in the HTTP headers the bearer token, right? Which means the DAB doesn't receive any claim. Since there are no claims, this value is empty, and therefore we cannot use it and we fall back to the anonymous. And anonymous means we can only see the values that are public. Now let me show you. Oh, okay. Let me show you what happens if I authenticate myself. To do that, let me just do it using GraphQL, for example. I think I have this somewhere already. Let's see. Nope. Okay. Let's do GraphQL. With GraphQL, it will be the same thing, right? Let me go to the to-do. So let's go to-dos, I want to show all the to-dos, right? So let's say the title. Now here you will see, and let me do here filter. I want to make sure that the category ID, well, it is not helping me. Let me just refresh everything. Filter category ID must be equal to, and is this 000 thing. Okay, let's go here. Okay, nice. So what I'm asking via GraphQL is return all the to-do, return the title and the title, and let's say also the owner ID, for but only limit to the to-do belonging to the category 000. Fine. No, this, I think this is, here we go. No, is that right? What I'm doing wrong? I think I have already it set to something else. Category D, yes. Okay, let me see something where okay, let's try this one. What is not working? Okay, here. There's something working. Probably I changed the, yeah, because I already have this here. Okay, let's just do that then. Let me just remove this for a second, and then I will figure out what I'm doing wrong. But basically, here you see that I only see the public now, all public. Now let me add the authorization token, and let me grab the token I have here, copy, and specify bearer, and then let me add this. And now I'm only seeing the few items I own. Because again, I'm only, basically, I am being allowed to see only the item my claim allowed me to access to. So again, you have row level security, basically. Just using the claims that, again, it's probably what you're already using, REST API or GraphQL. And everything I've shown, both in GraphQL and REST, always work, no matter if you're using GraphQL or REST. So we, basically, what I've shown you is that in a few line of code that at some point I probably made some mistake, but basically you configure the entity you want to publish. I've shown only tables here, but again, storage procedure and views are also supported. And then using the permission and the actions, you can define the policies, which allows you to define based on if someone is authenticated or anonymous, who can see what. If in your claims you also have roles, because when you get authenticated, you may your request may be assigned roles. You can even use these roles to define permission. So you can take this here, and let's say maybe that you want to create a role that says, for example, that whoever has logged in and has the role, let's say, to-do owner. Let's say that if I'm logged in, I have this role, I can do anything on anything I want. So you have role-based access control and also role-level-based security. So you can decide based on if I belong to a role or to something else, if I can access an entity, so the whole table. Once I can access a table, using the policies, you can decide which row I can access to. So you have a full control over security of your API and SaaS table, because those API are based on tables. Okay, that's it for my demo. That shows you how you can use Data API Builder. In the meantime, who is which computer, I will take some questions. But basically, what I want you to know is you can go to aka.ms/dub, and then you will be sent to the Data API Builder page, where not only you have the full source code, but then if you click on Docs, you will be sent to the official documentation where everything is explained in detail, how to install, how to set up security, and so on and so forth. Last thing before switching computers, How do you host Data API Builder? Well, on premises, wherever you want, on your VM or on your bare-bone machine. In Azure, you can run it in a container using Azure Container Instances or AKS or whatever, or using static web apps. That's another option where if you are using static web apps already, we integrated with static web apps, so Data API Builder is embedded in Azure Static Web App service. So you just have to configure the configuration file, and you don't have to deploy anything else. Just a configuration file, and will take care of everything for you. Any questions in the meantime? Let's switch. Yep, there are a couple of questions there. So yeah, please go on. I will just remove my computer and make space for Brian. Three questions we have. Yeah, let's start there. Yeah, go on. How do you? Versioning. We don't. So the question is, how do we version the API, right? Now, we don't do versioning at the moment for REST. GraphQL, in theory, doesn't need to handle versions. That was why GraphQL was born in the first place. But what you can do is have multiple versions of Data API Builder running on the same table or on the same database. And since you can choose which is the path at which Data API Builder will answer, you can have, I use API as my path, but you can call it V1. And that will go to the storage procedure that provides V1 feature. Then you can have another version running of Data API Builder running that answer to V2, and then point to a newer storage procedure, let's say. Make sense? Oh, if the question is, this is so good to be true, where's the trick, basically, right? I'm happy that you say that, but no, literally, the idea is that we have built what you have built on your own, just generalized so it works on any database. There are limitations, of course. For example, what you can do in terms of security is probably doesn't cover all the possible use cases. We try to focus on the 80% most common use cases. If you go out, what we support, for example, Data API Builder at the moment is not extensible. So if you want to, I don't know, manipulate the JSON before returning to the client, you can't. So there are some limitations, but we built Data API Builder to be the backend API for basic create, read, update, and delete API. If you need more than that, then you have to build on your own. Last question, and then we have, sorry, one here and, oh, there, okay. Oh, okay, so go here.
So first of all, what is Azure EasyAuth?
What is Azure EasyAuth? Azure EasyAuth is a simplification of authorization if you use Azure as your deployment solution, so that you don't have to manually configure. Have you ever been using Auth 2 manually? It's painful, right? Because you have to register the application, register the client, create. EasyAuth simplifies all of that. So if you want to use Twitter for providing authentication, you just select Twitter. And we did all the heavy lifting for you. Again, if it works, it's perfect. If you want to go outside what we have done, you have to do it on your own again. But if you just need like Twitter support or Facebook login, you just configure EasyAuth and it will provide it for you. So it's a kind of abstraction over Auth 2. The other question was there. Yep. Oh, yeah, sorry. Well, the repo for Data API Builder, or it's very easy, aka.ms/dub. And I will write it maybe once we have the 15 minutes question. Yeah, I will write it on the screen. But aka.ms/dab. But if you also Google now or Bing, Data API Builder, you probably find it very, very easy. Last question, and then I leave it to
So if you
Brian.
have more extensive business logic, it has to be
It could. It depends on the situation, yes. Otherwise, if you have really, really complex business logic, what you can do is use Data API Builder for just accessing the database. And then so imagine you have an Azure function that calls Data API Builder get the result, and then manipulate the result. Let's say that you need to transform JSON and inject other data. Or you could have storage procedure that does the logic for you if that suits your use case, absolutely. Can we keep it for the end? Oh, yeah, quick, promise. Oh, that's a very good question. So is IIS installed on SQL Server? Absolutely not. We created a .NET application that is completely stateless, so it can scale out as much as you want. So you run SQL Server on something, then you run Data API Builder on something else, a container, a fleet of machine, Azure, who cares? But it's completely separated, and Data API Builder will connect to SQL Server just like your application would do. We use SQL connection. We use .NET 6 to create Data API Builder. Okay, that's it. Brian, I think I used a lot of your time also, but you have 15 minutes of the FAQ.
Half an hour,
yeah,
give or take.
Go for it, man.
All right, so thank you very much. It was good to see that I haven't had a chance to play with it yet, but the wacky banana UI or whatever that is for the playing with GraphQL. That's a nice addition that they added. Or is that with 7.6?
It's iGraphQL Playground, yeah.
7.6?
7.6.
7.6, yeah. So if you do download it, you get the wacky banana, and you didn't show it, but OpenAI.
And OpenAI also.
Is also. So if you go that URL
Swagger.
API/Swagger, you get the Open API URL, and you get to see all the fun things and expose it and try it out and give it to your friends. So that's all in there. Great. So next we're going to talk about is services integration. So the question we get a lot from folks is, I am in Azure, or I have other services, and I'd like to use them with my database, whether it is something as simple as a function or something as wild as maybe using OpenAI. Since everyone has to use OpenAI, it's a thing. Well, we might as well use it as well. So Azure has many services. There's many platforms. There's many things you can do. So we said, why don't we make the database able to talk to these services so we can exchange data, we can do all sorts of fun things with it. So what we did is we built, or Davide built, HelpBuild, is what we're kind of calling, we're shopping the name around. It's in public preview right now, and it's available in Azure SQL database. It'll slowly eventually roll down to the managed instance in Azure, then to Box, which would be great as well, so you can use this on premises. But we're kind of calling it the external REST invocation, or as you see underneath the package name, if you've used it before, which is the SP invoke external REST endpoint. What it allows you to do is it allows you to call external REST endpoints in the Azure estate. So if you are using other Azure services and they have REST endpoints, you can now use this package within the database to call these other services. Very, very easy. And it uses authentication within Azure, so it uses managed identity, or you can pass it SaaS tokens, whatever you want, whatever you're using, you can now use that from within the database. Very cool function to do this with. Need a clicker thing here. That's okay. We'll go back. So Davide made this image a while ago, and I added the lower little section because yesterday it was Wednesday. I think yesterday was Wednesday. We did talk about and make the announcement that we are now able to go and talk to Blob Storage through this service with the latest release that was pushed out to Azure SQL, which is nice since we have this versionless thing. We can just kind of push out features and say, hey, there's something new in there, and you guys can go ahead and start using it. But that's what we did. We enabled Blob Storage usage from using this procedure. So for example, if you wanted to take some data and put it in a nice little file and dump it on a Blob Storage server, you can now do that with this, which I think was the demo that you showed yesterday. I'm taking some data out of the database, putting it into a format, and then dumping it off in a Blob Storage for someone to take a look at it. If you'd like, yes. Now, I know where you're going with that, but we'll talk about that in a second. Yes, so yes, we'll talk about that in a second. Eventing, the event train. So these are some of the services that you can call. There are a few more in there. So what are we going to use this for? What can we use this for? To start, it's a great way to activate workflows or to do notifications. So not on that thing, but Azure, I think we added it a couple weeks ago, and it may not be enabled or it may be enabled. We added the communication services, and you say Azure communication service? Well, we do. And you're able to use this to send text messages, to send emails, or make phone calls. And they gave me a phone number to use and try out. And we've had some disastrous fun with calling people from the database and having it just hang up on them. So you can do that if you wanted to have someone call people you don't like and have it hang up on them. You can write a script, loop through it, call all these people, and hang up on them, all from the Azure database. If you really wanted to do that, you can. But that is a good way to do a workflow. So again, alerting, something happens in the database page, this person sent an email, something happens, some event happens, you can now fire it from the database and call that service instantly on there. Data enrichment is another big one. I can take some data in the database or a column in the database, send it out to, say, a function that's going to go maybe geocode it, maybe do some foreign calculation for tax purposes, and then bring that data back and give me the answer, and then update that table with that new data. So that it'll allow you to call back and then get that answer, then apply it within there. Cache invalidation update, that's another one that we see a lot of people use. I invalidate the cache, I do an insert, update, and delete. I can go call out and then invalidate the cache, and here's my new value for the cache, or values for the cache. Complex processing, very similar, just calling something and kicking off a process from the database. Updating a website, SignalR. So this will use SignalR. So if I have a web page that is tracking progress or doing something, I can call that. It also works well with Power BI. So I can call Power BI and I can update data on a Power BI report in real time. And then my end users can see what's going on. So I got to have dials and dashes and things, all sorts of things moving, all fun things. Event-based architectures, which you did mention there, and we'll talk about it in a second. And then lastly is creating a data stream. I can create a data stream out. Now, one thing to preface this with is this procedure is called probably within a procedure or within a trigger. So what you're going to have to watch for this particular one, if you're going to use an event stream or that kind of a use case, is transactions. If it's inside of a trigger, I fire it. What if I roll the transaction back? Or what if it's not what if I didn't commit the transaction? So that's something that is aware, and we'll talk about how to get around that a little later. There's some stuff to do that. Just be aware that if you are sending things out while a transaction is going on, it will fire that REST service even if you roll it back. It's not going to go and grab that REST service and pull it back. It's not like an unsend that we have in Outlook or your mail client. It will fire it off. So you may have to do some cleanup within the event hover where you're going. So just make sure that you're aware of that situation with that. So this is the latest one, I believe, of all these services that you can use with Azure, in Azure with this procedure. We kind of set it where it's going to be. This isn't a doc, so you don't have to take a picture of this if you don't want it. It's in the docs. I mean, you could take a picture of it. Go right ahead. I made a pretty little chart in PowerPoint. Go ahead and use my handiwork there. So we kind of made it where there's an allow list rather than having a block list. This is to help so that you're not doing forgery attempts. You're not trying to take someone's system down. You're not trying to send out phone calls to people you don't like. You can use another service for that, which I told you how to do that. So it kind of allows you to kind of keep this within a box so that we don't get in trouble, people don't get in trouble, and you can't just do stuff, go out to other places. If you did need to go out to a third-party thing that is not in this list, you see in here somewhere is we have the ability to call the API, Azure APIs. So you can kind of mask it behind an API, call that API within Azure, and then that will make the call out via like API gateway or something. So that is, you can actually do it. So there's a way around it. So calling it is pretty easy. There's the package itself, or I should say the procedure itself. We give it a URL. You can give it a JSON payload. You may not need a payload. It could be payloadless. It could just be a call, a get. You're going to give it a header. Any headers you're going to have there. Now, if you jump down to the credentials quick, credentials can actually be set. And what we can do is we can use database scope credentials and then have that as our credential if we want to hide keys and secrets and whatnot and not put them in our call so people can see what's actually going on. We can set the credentials for this and then put that name credential in there, and it'll use that to create the header when it does the call out. But sometimes in here, you'll have a bearer token. Sometimes you'll have other things, and you can set that manually in here as well. So you can go either one for that. The method, obviously, we support all the regular REST invocation methods. Timeout in seconds. So how long you want this to time out. By default, it's 30 seconds. You can go all the way up to 260 seconds before this times out. So if there is something that it can't find, or it gets stuck, or it can't resolve the IP or the domain name and it times out, it'll time out after that certain to not lock the system or lock the transaction. And then responses and output, and that's usually going to be JSON or XML, depending on what you have back and what you set it as. So here's an example of one, and we'll just actually run this in the database as well. But this one is just basically calling a function. We're giving it a payload, and it's a post. So we're going to accept something back, or we're doing something with it. So it's a very simple procedure, but it does show that with this small bit of code, I can go call a function within Azure and get that answer back. So hopefully this will work, and we'll have so here we have it, and this is again just VS Code, and it's running against it's doing a SQL worksheet against a Azure SQL database. And again, this is exactly what you saw there. And I could just run this call, and if everything works, what it's going to do, it is going to say my return code is 0, which means successful, and then here is my return JSON payload. And then this is what, not the most elaborate function that I created, but it just basically gives you the return code, and then my result, it has the name that I gave it, and then a location. And again, that location could be anything. And that location could have been an input that I'm sending in, or it could go out and get it. But this just shows how easy it is in such a small bit of code to call a function within Azure. Now, granted, this function could have gone and, like I said before, done tax calculations or geocoded data or anything, or called another function. It could do whatever it needs to do. It's very easy to do it right from the database, as you see. Very small amount of code for this. I can slide this back. There it is. We have another example here, and this basically is calling OpenAI. So within Azure, we have OpenAI, and you can create your very own chat GTP server and talk to it all day if you want. It's actually very, 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 very inexpensive to create and talk. I think it's like 0.002 of a cent or something per some amount of tokens. And the tokens I have no idea how they calculate the tokens, but you can make a lot of requests. I haven't been charged yet, and I haven't been fired yet over my request to it. So I think we're good. And there's a dashboard that says how much you've charged. And I've hit this thing because we'll talk about this later, but there's a workshop tomorrow that uses this. I've been hitting it constantly for the past couple of weeks, and I haven't been charged more than 2 cents yet. So that's good. Yes? This is OpenAI. So it allows openai.azure.com as one of the endpoints you're allowed to go to. You could put that API behind a gateway, mask it, and then send it out. Or you could just use the one we have in Azure, because it's only 2 cents to use. So this is basically calling it. You'll see that for the headers, it does like the API key. That's not my API key, but that's where you put it there. And then you have the URL. This is the chat completions. And then you kind of give it the prompt text. And the prompt text is kind of strange. It's a little interesting how they have it, but in essence, the role is going to be your system, and the content is, why is the sky blue? I can ask ChatGPT that. It returns me a large piece of JSON, but the most part is, and that's what it actually gave me back. It says the sky's blue because of X, Y, Z, and so it just responded to what it is. You can combine this with data you have within the database. Now, if you follow Buck Woody, he had just recently put a blog out that went over using the database with ChatGPT to create ad copy for one of the AdventureWorks. I'm sure you've all used the AdventureWorks test database, one of the bikes in there. It says, here's the bike description, here's the bike name, write me some ad copy for this that I can send out to customers. And it goes out, it grabs it, it puts it all into the prompts, and it sends it over to ChatGPT, and you get the ad copy based upon what it was. And then you could also use, I think there's the Dolly end of this, where you can go give it some images, and it'll create you an image as well. So it does all that for you. And then you can have it put in your database. So you can get rid of your marketing firms and just use ChatGPT for it and send the data, and you'll get this wonderful copy back. So there you go. But it's very easy to do. And then I could take this JSON, grab the content, and then obviously insert it into a column or a row. Very easy to work with. Okay, so that was invoking REST endpoints using the service. Any questions on that quickly before we get to the next part? Yes? Why are we doing this? So we went over kind of the use cases of why you would use it, but it opens up the database world to everything that's out there for external data. Again, using functions to do calculations, using, being if you're on the developers and you're not too comfortable using stored procedures, I can put logic in my function because maybe I know how to write it in Python, C#, so and so and so and forth, put my logic there, send my data out, have whatever happens come, and then comes back in it, for example. It also does some cool things such as with Azure SQL Database, you may or may not be aware that you can't do cross-database queries. But if I use Data API Builder and I put that on this database over here, and then I have my database over here start using this query or this service, I can now talk to the other database and get information back and forth and share it between each other. So it opens up a database to the world of REST services as well as all those Azure services that you saw. So it really kind of opens up the world to do a bunch of cool things with your data that you wouldn't normally do, or you would have to move it out, put it into a data warehouse or put it on flat files and then do something and then pull it back. And that's all this code you have to write. We made it easy. It's a single procedure. You just send the API, you're done. That kind of answer your question? Yes? Not yet. It will be eventually. We're working on that right now, actually. In Azure SQL database. Yes. Yes. So if it has a status, it'll bounce back and say, here's my status of 500, 200, 400, 404, whatever. So you can always catch those errors within there. Again, it will always return the result that the REST service gave it, and then that's going to be your output, and then you handle it from there. Yes? It all depends on how much you throw it at. I mean, this performance, the overhead of this is very, very small. Again, there's not really a performance impact because you're just calling a REST service. And that REST service is, you're just basically doing HTTPS call, and that's it. There's not much overhead in that at all. Now, if you take that data and bring it back and do something with it, then that's where your overhead is. But just the call itself, there's not very little overhead because you're just doing a network call out. The what? Well, you could put this inside of a stored procedure. So you'd have a stored procedure that did something, put this inside the other call, and then when it comes back, it does something with that data that comes back. Or you can just call it alone. You can call it part of a task or a schedule. It just depends on what you want to do. I can call it a schedule and call something out and put data somewhere or update a dashboard, Power BI, as I said, the communication, send email, send alerts, or I can do data enrichment. I'll have an ended procedure, maybe an ETL. I'll go and do this. It's going to go get some data or go give data, do something with it, pull it back, and then insert it, process it, what have you. Lots of situations that you can use this in. So the next thing we're going to talk about is change detection and change stream. And we're going to do this in the guise of how do I leverage the database's change tracking features to create a change stream without having to code custom schedulers, custom packages, custom this, and all sorts of fun stuff like that, and have it be accurate. So this is where Azure SQL Bindings comes in. Anyone use or hear of Azure SQL Bindings for Azure Functions yet? There's a lot of Azure in there, a lot of blue. No hands here. Okay, so this is where we kind of lift out what we saw with some of the stuff we saw today, and we put it into the world of functions. So if you're more comfortable in the functions arena rather than the database arena, this may be for you. So everyone loves functions. You know, there's these serverless things that'll scale and do what they need to do. Pair it with the database, and then basically allow you to create these in the languages that you're most comfortable with, as long as it's these 6 languages that you're comfortable with, which is C#, JavaScript, Python, Java, and PowerShell, which is usually what the functions are going to do anyways. So there's 3 flavors, 3 types of functions. Now, when you think of these, you got to get away. We're not database people anymore. Now we're mid-tier stuff. Because if I hear as a database person an input, I think of an upsert or an insert or an update. And when I think output, I think of a select pulling data out. It's opposite here because we're at the function level. So an input, we're going to go get some data and input it into the function. So we're going to do a SQL call, go and get it and bring it out into the function. An output one is we're going to take something and apply it or upsert the database with it. And then the last one is a trigger. We're going to look at a table, and when data changes in that table, we're going to go do something. These are the 3 functions. The top 2 are in GA. They're ready to go. This one is in public preview. We'll hopefully have this GA'd sooner than later for everyone. A lot of people are trying to use that one. All right. So use cases are very similar to what we saw with calling the REST services from the database. You know, data enrichment, complex processing, updating the websites, integrate with event. Now this is a little bit easier going with the event because since we're using change tracking, the only thing that goes into a change tracking table are committed transactions. So this kind of helps you with that by saying, okay, if I use this for change tracking, change streaming, I'm only going to get those committed transactions out of the database. And then creating a change data stream is the other one. Few things with this. It does use OpenJSON. So your database compatibility has to be higher than 130, so SQL Server 2016 and greater. But it will work, since it's just a connection to a database, with Azure SQL, Managed Instance, SQL Server on VM in Azure, and it will also work if there's a connection from local to on-premises, or I should say from Azure to on-premises, if there is a connection. You just need to have that route so we can talk to the database. SQL bindings are going to use a connect string to connect. It does support managed identities. So if you have managed identities with your database, use that. If you're developing it locally, because we can do functions locally with the function core tools inside of VS Code or Visual Studio, you can use a username and password. Very easy to use it that way. But just know when you deploy it, you're better off using managed identities. And once you're in Azure with these functions using the trigger, there are 3 settings you can do. First one is the batch size, basically controls how many are processed at once when that trigger fires. So if you have a table that's doing lots and lots and lots of changes, you can set the batch size. You can set the polling interval. Since this is polling the database, by default it's 1 second. It's set in milliseconds, so it's set to 1,000. You can reduce it or increase it based upon what you want to do. And then lastly, max changes per worker. As these things start going, you get more and more and more, you set that number, and again, the function will scale. Since it's serverless, it will scale out for you, which is a nice option to have there. So this is the scenario that we see a lot of folks do and a lot of people are asking for, is I want to capture changes from a table and then put them in, say, the Azure Event Hub for downstream subscribers. So this could be microservices. This could be any of the things that happen with event hubs. Could be change stream analytics, could be fraud detection, could be any host of things. But I just want to go from the database there, and I want to write the absolute least amount of code as possible. So how do we do this? So here's the architecture that we're going to quickly show or quickly do here. So we have our database. Could be Azure SQL, again, could be Managed Instance, SQL on VM, could be on-premises. And we're going to have a table, and we'll do an update on a table or an insert. Doesn't matter. It's going to be a change. The trigger is going to see it. It's going to grab it. It's going to take that row or set of rows, and then have the batch side or how many changes there are. And then in that trigger, or in the function, it's going to send it over to the Event Hub and queue it up for you. It's that easy. And you can do all this in literally 10 lines of code. That's it. So very, very easy to do. So we have a demo. So what we can do is I'll show you how easy it is to use SQL bindings. So what we're going to do here is we will start off with just setting our thing up, or setting our database up. And here what we have is we have a table. Now this database we have is local. And you might have been at the keynote. This database is created with the SQL command go. I just did SQL CMD, create database, and bam, I got a database in Docker. So this is actually a database running in a VM, running on Docker. Just keep going down the path there. So we have this. We're just going to go ahead and we're going to create that table. And there it is. And then we're going to put some data in that table so we can actually work with it. All right, data's done. Table's done. We'll just get rid of all this. We don't care about that. OK. What we're going to do is we're going to create, for example, we're going to do an input. Now remember, input goes and does a select. But I'll show you how easy it is to create an input trigger. So I'll press F1, and I'll say, create an Azure function with a SQL binding. OK, great. Oh, you need a function project. Sure, not a problem. I already have some folders set up here. Do input. There should be nothing in there. Great. All right. I want a table. Input retrieves from a database. And here is my connection right here to my database that's local. It's going to say, all right, here are your databases on here. Which one do you want to use? This one, because I just created the table. And here is that customer table. A little fast here, but show you how it works. All right. There's my function name. Then it's going to say what you want your binding or your namespace to be. That's perfectly fine in namespace. And then open it in my current window. And it's going to go off and it's going to create my binding for me. All right, it's doing some code, doing some things. Do you want to include the password? This is where, if you're locally development, it's not a problem to include the password in your connect string because it's going to be you developing locally and no one's going to ever see this database. But again, when you deploy this into Azure or wherever you're going to deploy it, use managed identities. And don't save them. All right. So this is what once I trust that I do trust myself, this is in essence what it created right here. Very easy. So here is pretty much all the code that it wrote for me. And that's it. That's all that is for the binding code. Very, very simple to use. So with this code, and then we see that we have the select statement. So here's the select star. So this is doing a select star. If I wanted to actually constrict this, I could do select column A, B, and C if I really wanted to. But we're going to do select star. And that's it. We're all done. So if I just go here, view, and I'll view my terminal, and I'm just going to run a func start. It's going to start. It's going to build my project. And it's going to give me a URL in a second. And there's my URL. So if I open that URL, I'm going to go here, and there it is. There is my binding. It's also a REST service. So that function binding has created me a REST service where I can get data out of the database from this function. And I could write it in C#. I could write the binding in Python. I could write the binding in JavaScript, Java, or PowerShell if I'm really so inclined to do that. So anything that you're comfortable with, you can use these bindings. And we have all the samples for each kind of the language you want in our repository that's there. That's just using the C+, the C# binding, I should say. Now, change management, change streaming. So I happen to have one created because we only have 4 minutes left. And I want to leave some time for questions. I'm going to go ahead. I'm going to open a folder. And here's my trigger binding. I'm going to open it. And I do trust it. And here is the code. And even smaller, this is the trigger code. It's saying, here's my SQL trigger. This is my table it's on. And then for each row that it finds in the changes, do something. Now, this is just going to dump out to a log. But to send it to an Azure Event Hub, it is literally a single line of code that says, send this to the Event Hub. You just bring in the package that works with the Event Hub, and you just say, send it to this Event Hub. And once that change is hit, right over to the Event Hub for every row. Very easy to do. I actually have a blog post on this on dev blogs for Azure SQL Dev Blogs. It runs you through doing exactly this and sending it to an event hub. But we're just going to do this here. So what we're going to do is real quick, we're going to go back to our database because I forgot to turn change tracking on. And I'm going to grab my change tracking information here in my script. Quick, all right. And then here is my database. Create a quick query and I'll just dump this in. And we're going to turn change tracking on that table. All right, change tracking is on for that table. Now we're going to go back to our code. Here is my function. I'm going to start it. And hopefully it all works well. My binding will start. And this is all local. All this, everything I did here is local to my laptop. I have the core functions installed. I have the database installed. Everything's ready to go. All right, my trigger is working. So if you watch the bottom of the screen, what I'm going to do is I'm going to insert a row into that table. Pretend the bottom of the screen is an event hub. It's a big stretch, but pretend it's an event hub just for laughs here. And I'm going to run this insert. And there it is. The trigger saw it, grabbed it, put it wherever it needed to go. So you can do more complex stuff in the Azure function. You don't have to just go to Event Hub. You can do this with the data, do this, send it over here, do this, do whatever you want. Send it to streaming service, analytical streaming services, look for fraud detection, whatever you want. Send it to some random REST service or GraphQL service, or send it to another database, or send it to a data warehouse, or dump it out as a flat file to Blob Storage. Anything you want. Nice way to do it. And again, you saw the small amount of code to do it. And that was the C# code. Again, all the other languages do work. So that is SQL bindings in a nutshell very quickly. Now, finish this up quickly. If you want to try out everything we saw here, we in this very room have a workshop tomorrow morning. I don't know how many spots are left. There's probably a bunch of spots left. But if you want to come, you're more than welcome to do it. You'll be working with Data API Builder. You'll be working with static web apps to do authentication. You'll be working with Invoke REST API. You'll be working with database projects. And you'll be creating an app, very simple app, and working with all these to see how they all work, all these new functions. And then we also have it, and hopefully we'll get it to work because we just need a database. We have a bunch of data, well, all your databases will be in the private preview for the JSON in Azure SQL. So there's a whole workshop or a whole chapter on working with JSON, native JSON in the Azure SQL database and how to use the functions for that. And then lastly, there's an extra credit one that goes through creating that chain stream demo with the triggers. That is tomorrow at 8 o'clock, shameless plug. I think that is it. Yep.
Any questions?
Questions?
Still have 3 minutes. So.
So everything we do is it always starts with aka-ms. .ms. Everything is there because we can create these URLs wherever we want. So if you want DAB, it's aka.ms/DAB, D-A-B. If you want the SQL triggers, aka.ms/SQL triggers, SQL trigger, I believe. Or if you want this binding, so we kind of separate them so you can see them both, SQL bindings, aka-ms/SQL bindings. Go all 3 places. And in there's links to the documentation. There's the documentation itself. The repositories, all the sample repositories are for him. It goes directly to it. I should also note that the SQL binding, all that stuff, that's open source. So there's actually a repository behind that we maintain that is all open source for you to take a look at. And as I said, the input and output are GA, ready to be used. The trigger one is still in public preview. You're more than welcome to use it. Give us any feedback you want. But that should be going GA this year, hopefully. You didn't hear that from me, but I'm hoping to push that through. Yes?
So there's samples on it.
Yes, lots of samples. Lots of samples. And if you don't find anything you don't like, or you're missing something, or you want something, give us a call, contact us, let us know, and we will get that in there for you. Opening an issue for SQL bindings, it's just right in GitHub. So you just open an issue, open a feature request, function request, say hi, whatever you want. Just go ahead and do it in there. Yep,
Yeah,
and
yeah,
same
yeah.
thing for DAB. DAB is in there as well.
Yeah, question there. Yeah. Mm-hmm. Yeah. I see. So the question is why basically we have the configuration returning to the API builder. The security configuration is in the configuration file, because maybe as a database administrator you don't have much to say on what the developer want to give in terms of security. You just know that the application needs to be able to access a table, and then the developer will choose who can access to which row. That's the typical scenario, for example, for a shopping cart, right? You don't decide who can access the table, the value in the shopping cart, because it's a public website, so anyone can access as long as they can only access their site, their data. If instead you said, no, I have a situation where I am the DBA and I need to make sure that on SQL, the security is enforced, for example, using row level security, you know that SQL Server supports row level security natively, you can. So it really depends on the scenario you have. As a DBA, unless you are also working with the developer, you only have to give the application, in this case, Data API Builder, access to the table. Then it will be Data API Builder to decide which request can access the data in the table. Is that clear? Otherwise, yeah, let's talk offline. Otherwise, if I was not clear enough. And I'm sorry for that. Any other questions? Okay, I think we exactly on time.
Kind of.
Thank you so much. Thank you.
Thank you.